Hi friends, welcome to Talent Sprint's Banker's Choice program. In this session, we are going to discuss about coded inequalities. Coded inequalities is all about comparison of two variables based on a particular parameter. Whenever we compare two variables, there are three possible conclusions. That is, let's say we are comparing the two variables A and B. So the conclusions which we can make out are A can be less than B, or A can be greater than B, or A can be equal to B. So in general, these are the three basic comparisons which can be made from two variables comparison. That is, either one of them is less than the other, or greater than the other, or both of them are equal. Now with this knowledge, let us first understand what are the various types of inequalities that we have. Now if you look at the first statement here, it says A is neither greater than nor equal to B. So when we say that A is neither greater than nor equal to B, the only possibility is A should be less than B. So we can say that A is less than B. Now if you look at the second one, it says A is neither smaller than nor equal to B. So A is neither smaller than nor equal to B. So the only left out possibility is A should be greater than B. So we can say that A here is greater than B. The third one says A is neither greater than nor smaller than B. So it is neither greater nor smaller. So the possible comparison between A and B should be A is equal to B. If you go for the next one, it says A is not greater than B. So the only information which we have is A is not greater than B. If A is not greater than B, there are two possible comparisons. Either A can be less than B or A can be equal to B. So by combining these two here, we can say that A is less than or equal to B. So A should either be less than B or it can be equal to B, but it cannot be greater than B. Similarly, in the last case, we see that A is not smaller than B. So when A is not smaller than B, we can have two possible conclusions. That is either A greater than B or A equal to B. So by combining these two now, we can say that A is greater than or equal to B. So these are the five basic type of inequalities that we have. Remember that whenever we compare two variables, the sample space will be any of these three cases. That is either A is less than B, or A greater than B, or A equals to B. So based on the given conditions, we can have a combination or any one of these three comparisons. Now, to solve questions based on coded inequalities, we need to understand the three basic rules. So let us first look at these three golden rules and then we shall take up some examples. Let us now understand the rule number one of comparison, which is based on similar inequalities. Let's look at the example here. Let us assume A is greater than B and A is greater than C. When we know that A is greater than B and A is greater than C, then we can say that B and C cannot be compared. That is, B can be greater than C, or B can be less than C, or B can be equal to C. All the three cases are possible. So whenever we have a similar inequality, as you can see here, greater than and greater than are similar inequalities, and we have the same variable on one of the sides, then the other two variables cannot be compared. That means B can be greater than C, or less than C, or equal to C. To understand this better, let us assume that A, B, C are three students and we are comparing the heights of these three students. So if you look at the first case here, it says A is taller than B and A is taller than C. So from this we can say that A is taller than B and C. But among B and C, who is taller and who is shorter cannot be established. So that is the reason we say that B and C cannot be compared. Among B and C, B can be taller than C, B can be shorter than C, or B can be equal to C. So the simple idea here is whenever we find similar inequalities and the same variable on one of the sides, the other two variables cannot be compared. The other such possible cases are this one, that is A less than B and A less than C. Here also you see that there are similar inequalities between the two comparisons and we have the same variable. Similarly, we have A less than or equal to B, A less than or equal to C, or A greater than or equal to B, A greater than or equal to C. Otherwise, we can also have a combination of less than and less than equal to, or greater than, equal to, and greater than. So in all these cases and many other similar cases, the answer should be B and C cannot be compared. So that is one of the most important rules required when we are solving questions related to coded inequalities. Let us now take the rule number 2 from coded inequalities, where we compare any two variables from the given inequation. Let us take an example. As you can see here, a number of variables have been compared and the relationship has been established as given in the inequation. The inequation here is A less than or equal to B less than C less than or equal to D less than or equal to E. Let us now understand how to compare any two variables from this given inequation. For example, the relationship between A and B is directly known to us, that is A less than or equal to B. But how to compare the variables A and C? So let us see how can we compare the two variables A and C. If you observe, the two inequalities between these two variables A and C are A less than or equal to B, B less than C. So the two inequalities are less than equal to and less than. So the relationship between A and C will be that one which is common for both the inequalities. Now if you observe, the common part in both the cases here is less than. So we can say that A is less than C. Similarly, if we try to compare A and D, the different types of inequalities which we have here are less than equal to, less than and less than equal to. Again, if we observe, the minimum common part in all these three inequalities is the less than part. So we can say that the relationship between A and D should also be A less than D. Remember, here we have three inequalities between A and D, less than equal to, less than and less than equal to. We cannot take the relationship as less than or equal to. Why? Because equal to part is not available between B and C. So we should consider only that part of the inequality which is common for all the three inequalities. Again, if we try to compare the variables A and E here, the different types of inequalities we have are A less than equal to B, less than C, less than equal to D and less than equal to E. So out of all these different inequalities, again the common part in each one of them is less than. So we can say that A is less than E. Remember, again we cannot take the relationship as A less than or equal to E, because here we don't have the equality part. So the common in all the four cases is less than. So we should take that as the relationship. So the idea here is, whenever you are comparing two distant variables which have got two or more than two inequalities between them, we should always consider only that part which is present in each of the inequalities. Let us now take another example here. Let us say we are comparing the two variables C and E. If you observe, the two inequalities between C and E are C less than or equal to D, D less than or equal to E. Now in both the inequalities we find that they are same, that is less than equal to and less than equal to. So the common part in both the cases is less than equal to itself. So now we can say that C is less than or equal to E. But once we compare B and E, we see that the relationship will be different. If you observe the variables B and E, in between we have less than equal to and less than equal to. Out of these three, the common part in all the three cases here is less than. So here we can say B is less than E. Remember, we cannot take less than or equal to as in this case, because in this case in both the inequalities we have equality sign. But if you compare B and E, we have three inequalities in which one of the inequalities doesn't have the equality sign. So the only relationship between B and E should be taken as less than, but not less than equal to. Whereas in case of C and D, we can take it as less than or equal to. So I hope the rule here is clear to all of you. The simple idea is, whenever you compare two distant variables, just see all the different inequalities present in between them and take out the minimum common part which exists in all the inequalities. Let us take another example based on the same rule. So the second example here is as shown. We can see that P is greater than or equal to Q, greater than or equal to R, greater than S, greater than T, greater than or equal to U. Again, the same rule is applicable when we are comparing two distant variables in this sort of an inequation. Let us try to understand the relationship between P and S. As you can see here, the various inequalities we have are greater than equal to, greater than equal to and greater than. And the common part in each one of them which exists here is greater than. So we can say that P is greater than or equal to S. When we compare the variables R and U, again we see that the different inequalities are greater than, and greater than or equal to. So we can say that the relationship between R and U should be greater than. Remember, we cannot take greater than or equal to as the relationship here because equality is missing in these two cases. Now, when we compare the variables R and T, we find that the two inequalities between them are greater than and greater than. So it is obvious that the relationship between R and T should be R greater than T. So this is how you can understand the relationship between two distant variables. The simple point which we need to follow is whenever we compare two distant variables, just take the minimum common part which is available in all the inequalities between them. Let us now understand the third and the last rule from coded inequalities, where we compare two variables with dissimilar inequalities present in between them. Let us take an example here. As you can see, A is less than B, less than equal to C, greater than D, greater than or equal to E. So this inequation has got dissimilar inequalities. Dissimilar inequalities are nothing but combination of less than and greater than symbols. So if we try to compare two variables such that there are dissimilar inequalities between them, then again the relationship cannot be determined. For example, let us assume we are comparing the variables A and B. As you can see here, A is less than B, B less than or equal to C, and C greater than D. So once we find two dissimilar inequalities between any two variables, we can say that the relationship between them cannot be determined. Therefore, A and D have got no definite relationship between them. A can be greater than D, or it can be less than D, or it can be equal to D. All the three cases are possible. So simply we can say that the relationship between A and D cannot be established. Similarly, if we try to compare the variables B with variable D, we find that there are dissimilar inequalities. So again here the relationship cannot be determined. And the same thing happens when we compare the variables B and E. Again in between B and E we have less than equal to, greater than and greater than equal to. So as there are dissimilar inequalities between them, those two variables cannot be compared. So the simple idea here is whenever we find dissimilar inequalities, that is a combination of less than equal to, greater than equal to, or less than with greater than equal to, or less than equal to with greater than, all these are referred as dissimilar inequalities. So whenever we have these two types of inequalities present between two variables, those two variables cannot be compared. That means the relationship between the two variables can be either less than or greater than or equal to. So that is the third and the last rule to be understood to solve questions from coded inequalities. Let us now take the first model from coded inequalities, where different symbols are used to represent the relationship between two variables, based on which we are supposed to find out which of the given conclusions are true. First of all, let us understand the given question here. It says A@B means A is greater than B. So wherever we find the @ symbol, we should replace that with the greater than symbol. Similarly, A#B means A is less than or equal to B. $B means A less than B. A*B means A is equal to B. And the last one here is A∩B or A∩B means A is greater than or equal to B. So this information is given to us where each symbol has been represented with an inequality. Now the question here has got some statements, that is L#V, V$E, E∩U and U@B. And it has got three conclusions, B$E, L$E and B*L. What we need to do here is assume that the given statements are true, and then we have to find out which of the given conclusions follow the given statements. Now to solve this question, we first of all need to replace each of these symbols with the proper inequality. So here we can say that L#V, we know that hash is nothing but less than or equal to. So we can say that L#V is nothing but L less than or equal to V. The second statement here is V$E. We know that dollar is nothing but less than. So we can say V less than E. The next statement is E∩U. Cap means greater than or equal to. So we can say E greater than or equal to U. and the last one is u@b. So by replacing with the greater than symbol from the given information, we get u greater than b. Now, once we have replaced each of the symbols with the proper inequality, let us now find out the combined statement. That is, let us try to join all these four parts into one inequation. That is, if you observe, we know that L is less than or equal to V, and the next part here is V less than E. So if we try to merge these two statements, V gets removed and we get L less than or equal to V, V less than E. Similarly, let us now join these two statements. So we get V less than E and E is greater than or equal to U. So by combining that, we can simply replace here as E greater than or equal to U. And the last part is U greater than B. So we can say U is greater than B. So this is the combined statement which we have got from the given question. And now we need to decide which of these conclusions are true. Again, we need to first replace these symbols with the proper inequality. So we know that in the first one we have $E, which means B less than E. The second one again is $E, so L less than E. And the third one is B star L. And from the given information we know that star is nothing but equal to. So we can say B is equal to L. Now if you observe the first conclusion, here B and E have been compared. And the conclusion here is B less than E. So let us try to find out the relationship between B and E from the statement given in the question. Now if you look at the statement here, we know that B is less than U. Remember, U is greater than B. So when we come from the reverse side, we can say B is less than U and U is less than or equal to E. So if we try to observe B less than U, U less than or equal to E. So the relationship between B and E here will be B less than E. Since there are two similar inequalities, we need to consider the common part between them as a relationship here. So if you observe, less than is the common part in these two cases. So we can say B is less than E, and that itself is the given conclusion. So we can say that conclusion number 1 is true. The second conclusion here is L less than E. The given statement is L less than or equal to V, V less than E. Now again, based on the second rule, we know that whenever we have similar inequalities, we can consider the common part between them as the relationship. So we can say that the relationship between L and E should be L less than E, as the less than inequality is present in both the inequalities here. So the relationship between L and E should be L less than E, and that itself is given in the conclusion. So conclusion number 2 is also true. The third and the last conclusion is B equals to L. If we try to compare B and L here, we come to a conclusion that B and L cannot be compared as we have dissimilar inequalities between them. So B and L cannot be compared. That means B can be less than L, B can be greater than L, or B can be equal to L. All the three cases are possible. Whereas the given conclusion says B is equal to L, which cannot be true. So conclusion number 3 is false. So our answer for this question should be 1 and 2 are the two conclusions. Let us now take the second example based on model 1. We have already learned all the different symbols with their meanings. Only the statements and conclusions have been changed. Now the statements given here are $T, T star R, R@H and there are 3 given conclusions. We need to find out which of these conclusions are true. So as already discussed, first we need to replace each of these symbols with the correct meaning from the given information, and we need to form a consolidated statement from all these 4 parts given to us. Let us try to find out the correct statement with the help of the given information. We know that $T, dollar means less than, so we can say M less than T. The next part here is T star R, and star means equal to, so we can say T is equal to R. Now friends, instead of writing T equals to R separately and then combining the two statements, let us directly try to merge them. I know that T is equal to R, so we can simply write T equals to R. The third part here is R@H, and from the information given there we know @ is greater than, so we can say R greater than H. And the last statement here is H#G. Hash means less than or equal to, so we can say H is less than or equal to G. So one point which you have observed here is we are not writing the statements separately and then trying to merge them. Instead, we can directly merge all the variables with the help of the given information. So don't waste your time in writing each of the statements and then merging them. Let us now try to replace the symbols in all these conclusions. The first one here is $h. Dollar is nothing but less than. So we can say M less than H. The second one is R@G. At the rate is greater than. So we can say R greater than G. And the third one is M#R. Hash means less than or equal to. So we can say M less than or equal to R. We now need to find out which of the given conclusions are true. The first one here is between M and H. M less than H. If we try to look at the statement here and compare M and H, our conclusion should be M and H cannot be compared, because here we have dissimilar inequalities between them. That is rule number 3. Whenever we have dissimilar inequalities between two variables, those two variables cannot be compared. And cannot be compared here means M can be greater than H, can be less than H, or it can be equal to H. But the statement says it is less than H, which may not be true always. So conclusion number 1 is false. The conclusion number 2 is R greater than G. If we try to compare R and G, we find that there are dissimilar inequalities between R and G. That is, one is greater than, the other is less than or equal to. Again, by applying rule number 3, we can say that R and G cannot be compared. Why? Because R can be less than G, can be greater than G, or can be equal to G. But the given conclusion says R is greater than G, which may not be true always. So even conclusion number 2 is false. And the last one here is M less than or equal to R. If we try to compare M with R here, we know that M is less than T and T is equal to R. Now equality means these two variables, that is T and R, can be interchanged. So what we can say here is M is less than R, which is nothing but T. So the only point which we can make out here is M is less than R, but the given conclusion says M is less than or equal to R. So even conclusion number 3 is false. So our answer here should be all the 3 conclusions are false, none of them is true. Remember friends, in the last case you are seeing that we have a less than symbol and an equal to symbol. Doesn't mean that the combination will be less than or equal to. The answer should be M less than R. That is the reason the third conclusion is false. So the answer here should be all the conclusions are false, none of them is true. Let us now take another example based on the model that we have just discussed. Here again the information given remains same, only the statements and conclusions have changed. So the statements are T#W, W$Q, Q∪D and D@G. So let us first find out the correct inequation and then verify which of the given conclusions are true. So we know that hash is nothing but less than or equal to. So we can say T less than or equal to W. W$Q. Dollar means less than. So we can say W less than Q. So we get W less than Q. Q∪D. Cap is nothing but greater than or equal to. So we can say Q greater than or equal to D. And the last one here is D@J. And at the rate means greater than. So we can say D greater than J. So this is the consolidated statement that we have made out of the given statements. Now the 3 conclusions are J$T. Dollar is nothing but less than. So we can say J less than T. The second one here is T#J. Hash is nothing but less than or equal to. So we can say T less than or equal to J. And the last one here is T$Q. So dollar here is nothing but less than. So again we can say T less than Q. So these are the 3 conclusions, and now we need to check how many of them are correct. Now keeping in mind those 3 rules, let us just quickly find out which of the given conclusions are true. The first one here is J less than T. So let us try to compare J and T from the statement that we have obtained. If you try to compare J and T, the different inequalities we have in between them are less than equal to, less than, greater than equal to and greater than. That means very clearly we have got dissimilar inequalities between T and J. And from rule number 3, we know that whenever we find dissimilar inequalities, the 2 variables cannot be compared. And cannot be compared here again means T can be less than J, can be more than J, or can be equal to J. So the conclusion number 1 here is false, as it only says J is less than T, but J can be greater than T or it can also be equal to T. So conclusion 1 is false. Moving to conclusion number 2, we know that T is less than or equal to J. Let us now compare T and J. Again, the same rule is applicable. We have dissimilar inequalities between them, and hence t and j cannot be compared. So we simply cannot say that t is less than or equal to j. Why? Because it can also be greater than j. So even conclusion number 2 is false. And the last conclusion here is $Q. That is nothing but t less than q. And by comparing t and q, we find that the different inequalities between them are less than, equal to, and less than. From rule number 2, we know that whenever we have similar inequalities, we need to consider the minimum common part. So the common part here, which is there in each one of them, is less than. So very clearly, the relationship between t and q should be t less than q. So conclusion number 3 is true. But friends, there is one important point which is to be noted here. If you observe conclusion numbers 1 and 2, independently they are false. But then conclusion number 1 says j less than t, and conclusion number 2 says t less than or equal to j, which is nothing but j greater than or equal to t. So if you now try to combine conclusion number 1 and 2, we find that j is less than t in conclusion 1. In conclusion 2, j is greater than t, or j is equal to t. That means we have already learned that there are 3 types of comparison, either less than or greater than or equal to. And by combining the first 2 conclusions, we get each one of them, j less than t, j greater than t, and j equal to t. So independently, conclusion number 1 and conclusion number 2 are false. But if we combine conclusion 1 and 2, any one of them has to be correct. Why? Because the complete sample space is included in both the conclusions here. So we can now say that conclusion number 3 is definitely true, but at the same time, either 1 or 2 has to be true. So the answer for this question should be conclusion 3 and either 1 or 2 must be true. So friends, one important point which we have learned here is whenever we have different conclusions, if a combination of any 2 of them covers the complete sample space, that is less than, greater than, and equal to, we have to consider them as either 1 or 2 has to be true. So here either 1 or 2 is true and 3 is definitely true. So that is our answer. 3 and either 1 or 2 must be true. Let us now take the second model from coded inequalities, which is comparatively simple when compared to model number 1. Here we are not given with different symbols for each of the inequalities. Instead of that, the statements are directly given to us and we just need to check which of the conclusions are true. So the first example here is the given statements are t less than r less than equal to u. The second one is l greater than u less than or equal to k, and the third one is p greater than or equal to r. And the 2 conclusions are k greater than equal to r, and the second one is l greater than r. So from these statements, we need to find out which of these conclusions are true. So as you can see here, we don't have different symbols which have to be replaced with inequalities and then find out the correct conclusions. Let us simply work out as we have discussed earlier and find out which of the conclusions are true. Now, if you look at conclusion number 1, the variables k and r have been compared, and the given conclusion is k is greater than or equal to r. Now, in the given statements, we have the variable k in statement 2 and the variable r in statement 1. So, before we compare k and r, we just need to see how to connect these 2 statements. To connect these 2 statements, we should have a common variable in between the 2 statements, and that common variable is nothing but the variable u. So with the help of u, we can join these 2 statements and try to establish the relationship between k and r. So let us try to establish the relationship between k and r with the help of variable u. So if we try to read from this side, we know that k is greater than or equal to u. Remember, u is less than or equal to k, but when we go from the other side, we should say k is greater than or equal to u. So k is greater than or equal to u, and u is greater than or equal to r. So we can say u greater than or equal to r. And from this, if we try to compare the variables k and r, we know that the definite relationship between them should be greater than or equal to, as we have 2 inequalities and both of them are same. So the obvious relationship between K and R is K greater than or equal to R, and that is given in conclusion number 1. So conclusion 1 is true. Similarly, let us try to establish the relationship between L and R. Again, if you observe, the variable L is in the second statement and R is in the first statement. So we need to join these two statements with the help of a common link, and that link is nothing but the variable U again. So we can say L greater than U and U is greater than or equal to R. So U greater than or equal to R. Now from this statement, we know that if we apply rule number 2, that is whenever we have similar inequalities, the common part should be considered as a relationship. So we can say L greater than R, and that is given in conclusion 2. So even conclusion number 2 is true. So the answer here should be both conclusion 1 and 2 are true. So as you can see here, there is not much of difference from model 1 to model 2. The only thing is we need to connect the given statements with the help of a common variable and then find out which of the conclusions follow. Let us take the second example based on model 2. The statements here are D greater than H greater than or equal to N, S greater than I less than or equal to H. The first conclusion is N less than or equal to S, and the second one is I less than D. Now if we try to compare the two variables N and S, we find that N is present in the first statement and S is there in the second statement. So first we need to join these two statements with the help of a common variable, and that common variable should be the variable H, which is present in both the statements. So let us try to combine these two statements with the help of H. So we can say that N is less than or equal to H, H greater than or equal to I, and I is less than S. Now if we try to compare N and S, we know that in between N and S we have got dissimilar inequalities, and from rule number 3 it is very clear that whenever we have dissimilar inequalities, the variables N and S cannot be compared. So here the given conclusion should be taken as false, because it says N is less than or equal to S, but N can also be greater than S. So conclusion number 1 is false. Let us now look at the conclusion 2. It says I is less than D. Let us now try to connect the variables I and D with the help of H. So we find I less than equal to H, H is less than D, H less than D. Now if we compare the variables I and D, we have two inequalities, less than equal to and less than. And very clearly we know that the relationship between I and D should be less than. That is the common part between these two inequalities. So we can say I is less than D, which is given in conclusion number 2. So conclusion 2 is true. So the answer for this question should be only conclusion 2 is true. Let us now take the third and the last example from model 2 of coded inequalities. The statements are H equal to I less than equal to R, M greater than equal to R, R less than S. The first conclusion is M equal to I, and the second conclusion is M greater than I. So let us try to find out the relationship between M and I. As you can see here, M is in statement 2, I is in statement 1, and the connecting variable should be R, as it is present in both the statements. So if we try to combine these two statements, we find that M is greater than or equal to R, and R is greater than or equal to I. So we can say R greater than or equal to I. Now if we try to find out the relationship between M and I here, we have two inequalities. Both are greater than or equal to. So it is obvious that M should be greater than or equal to I. Now if you look at conclusion 1, it says M equal to I. Therefore, conclusion number 1 is false, as we know M is greater than or equal to I. So we simply cannot say M is equal to I. The conclusion 2 is M greater than I. But here we know that M should actually be greater than or equal to I. So even conclusion number 2 is false, since it only considers the greater than inequality but not greater than or equal to. So conclusion number 1 and conclusion number 2 are false independently. But again, if you observe, if we combine these two conclusions, we come out with a relationship that M is greater than or equal to I. And that is what is the correct relationship between M and I. So we can say that conclusion number 1 and conclusion number 2 independently are false, but the combination of 1 and 2 has to be correct. So we can say that either 1 or 2 must be correct. So the answer for this question is either conclusion 1 or 2 is true. So friends, as we have seen in this session, the questions from coded inequalities can be solved with the help of the 3 golden rules that we have discussed in the beginning of the session. So whatever be the type of question, just try to follow the given rules and you can get the answer in a very easy manner. That's all from Coded Inequalities. See you in the next session. Thank you.